Okay, so we have a ball player that's going to hit a ball. The ball is 1.1 meters above the ground. And when the ball is hit, we do not know that initial velocity. It's hit at 35 degrees, and it's going to go 123 meters in the x direction, and it's going to go over the wall 18.2 meters high out there at that 123 meter mark. So when we think about how high the ball goes up, it goes up 17.1 meters because you're 18.2 minus the 1.1. So you create the table that is here in front of us with the initial velocity in the x, the initial velocity in the y, the accelerations in the x, the accelerations in the y, your position in the x, your position in the y. And you realize that you have to solve this simultaneously because you have two unknowns. You only have two pieces of data for x, 0 and 123 meters, 0 meters per second squared, 123 meters. You only have two pieces of information for the y, which are negative 9.8 meters per second squared and 17.1 meters. And so you have to solve this simultaneously because v initial and time are both not known. So you create a set of equations using x equals v initial t plus 0 because the acceleration is 0. So you would have 123 is equal to 123 is equal to v initial cosine 35 times t. That's two unknowns. And so there's two ways of solving this. The easiest way of solving this is to solve it for v initial. And so I would say v initial is equal to 123 divided by the cosine of 35t. And I can plug that into my calculator and do 123 divided by the cosine of 35. And when you do that, you end up with 150.2 t. So that's v initial is equal to 150.2 t. You then have your y values. So y is equal to v initial t minus 4.9, which is half of 9.8 t squared. And so when you plug this in, you have y is equal to v initial sine of 35 times t minus, again, 4.9 t squared. So v initial, you would substitute in, and so you could, in reality, you could bring this over and substitute it in right there. And the cosine of 35 and t actually cancel out. Now, I should have put in here the y value of 17.1. Remember 17.1. But, or you could put in terms of substituting this in, you could put in the 150.2. Actually, that should be over t, shouldn't it? It shouldn't be. It should be over t. That should have been over t there. But because the t was in the denominator. But you could substitute that in at this point in the 35 and the cosine, all that stuff, simplify out to tangent. That's another option, whichever one you prefer. So when I go to do that substitution here, I get 17.1 is equal to 150.2 over t times the sine of 35 t. The t's cancel out. That's going to be a big help for us, minus 4.9 t squared. So simplify this thing down to 17.1 is equal to 150.2 sine of 35, which is 86.2 86.2 minus 4.9 t squared. So I'm going to subtract the 86.2 from both sides. I'm going to come up here with this. I'm going to subtract the 86.2 from both sides. And I end up with 69.1 is equal to 4.9 t squared. I also divided by the negatives, right? And so I divide both sides by 4.9. And when I do that, I get 14.1 is equal to t squared. So I take the square root. And when I take the square root of that, I end up with square root of 14.1 gives me 3.75 seconds. So now I have the time, 3.75 seconds. Once I have the time, I can plug that back in. I can bring that back over and plug it in, and I can get that initial velocity. So 150.2 divided by 3.75 gives us an initial velocity of about 40.1 meters per second. So I have the initial velocity. And then using the kinematics, now I have all this data, using the kinematics, if I wanted to find the final velocity, I would be able to do that.